In this video, I'll be going over 20 random problems from a college algebra final exam. Let's get to it. In problem number 1, we want to distribute this -2. So -2 times 3x is -6x. -2 times 1 is -2. Bring down the less than or equal to, and just write the right side. Next, we want to get all of the x terms to one side of the equation. I will move them to the left by subtracting 4x from both sides. This will give me -10x minus 2 is less than or equal to -6. Next, I will move the numbers without x's to the right side by adding their opposite. So adding 2 to both sides, we get -10x is less than or equal to -4. At this point, we just need to divide both sides by the number attached to x. -10 divided by -10 cancels to be 1, and 1 times x is x. The right-hand side, -4 over -10, simplifies to +2/5. Basically, we could divide the top and bottom both by -2 to simplify that fraction all the way. We need to keep in mind that when we divide both sides by a negative, the direction of this inequality will change. So the answer is x is greater than or equal to 2/5. If they wanted you to put that answer in interval notation, then the first number in the solution is 2/5. In interval notation, we put a comma. Any x bigger than 2/5 means this goes up to +infinity. So the highest number in that solution is infinity. Infinities always get parentheses around them in interval notation, and this number would either get a parenthesis or a bracket based upon whether it can equal that number. And since it can equal 2/5, we put a bracket here. So bracket 2/5, comma, infinity, parentheses is the answer in interval notation. Problem number 2 is an absolute value equation. Solve absolute value of 2x minus 5 equals 7. When we have an absolute value equation, we want to set what's inside the absolute values equal to positive of the right-hand side here, or it could also equal negative to the right-hand side. Now we're just going to solve these equations. So add 5 to both sides, we get 2x equals 12, and divide both sides of the equation by 2 to get x equals 6. On this other one, add 5 to both sides. This time we will get 2x equals -2, and we'll divide both sides by +2 and get x equals -1. I encourage you to check your answers during the test. 2 times 6, if we put in a 6 here, minus 5, it should equal, so that's a question mark, 7. And absolute value of 2 times -1, both of these answers, we need to check them. Minus 5, and that should equal +7 as well. So we're getting 2 times 6 is 12, minus 5, that's indeed 7, and the absolute value of 7 is 7. So this checks. 2 times -1 is -2, minus 5, which is -7, and the absolute value of -7 is also 7. So this one checks as well. So you have two solutions there, x equals 6 and x equals -1. Number 3 involves solving a quadratic equation by factoring. To see if this trinomial is factorable into two binomials, we need to see if there are two numbers that will multiply to be positive 6, and those same two numbers should add up to negative 5. We know that to find x squared, we just need to multiply x times x. So we need to think about all the numbers that multiply to be positive 6. 1 times 6, 2 times 3, negative 1 times negative 6, and negative 2 times negative 3. If we change the multiplication to plus and add these up, we get 7, 5, negative 7, and negative 5. So this is the combination we want. The two numbers that multiply to be positive 6 and add up to negative 5 are negative 2 and negative 3. Next, we can use the zero factor property that states if two factors multiply to equal 0, then at least one of those factors equals 0. So we set these equal to 0 to solve. Add 2 to both sides on the first one, and we get 2 as a solution. Add 3 to both sides on the second one, and we get 3 as a solution. So the answers are x can be 2 or x can be 3. If we plugged in 2 or 3 here and multiplied this all the way out, added 6 to it, we should get 0. Number 4 is a quadratic equation that is not factorable. When they are not factorable, we typically use the quadratic formula or completing the square to solve them. I'm going to use the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. Our a value is the 2, our b value is positive 3, and our c value is negative 5. We're going to substitute that in first and then simplify the fraction. So negative b goes in the numerator. If b is 3, then negative b is negative 3, plus or minus square root of b squared, which is 3 squared. The formula says minus 4 times a and times c. A is 2, c is negative 5. And the denominator is always 2 times a, and our a value is also 2. We just simplify this step by step. Under the square root, we're going to get 9 here. And negative 4 times 2 is negative 8, times negative 5 is positive 40. So under the square root, we will have 9 plus 40, which is 49. And the denominator is 4. Next, we'll take the square root of 49. Since 49 is a perfect square, it works out to be a whole number, which is 7. We need to keep in mind that there's going to be two values in the numerator, negative 3 plus 7, and the denominator is 4, and negative 3 minus 7, and again the denominator is 4. So these are two different solutions. We just got to figure out what they are. So negative 3 plus 7 is 4, and 4 divided by 4 is 1. So that's one of our answers. And negative 3 minus 7 is negative 10 over 4. Negative 10 fourths simplifies to negative 5 halves. So our two answers are 1 and negative 5 halves. This next problem involves polynomial division. We are able to perform synthetic division on this problem because we have a 1 in front of x and we have a minus or plus a number here in the denominator. So since it's x to the first power, this is going to be an easy problem to do by synthetic division. So remember, with synthetic division, we take this number and change its sign, so it's a 1. And we will just write the coefficients of all these terms up here, 1, negative 4, 5, and negative 2. So 1, negative 4, 5, and negative 2. And draw a line here for the addition and subtraction step. And you want to make sure you leave enough room in this row for the numbers you get when we multiply. So the very first step of synthetic division is dropping down this number to below the line. So we bring down the 1, and now we multiply by this 1 out here. So 1 times 1 is 1, and we put it here. Then we just add these up straight down. Negative 4 plus 1 is negative 3. And again, we do the multiplication step. 1 times negative 3 is negative 3. Add these up. 5 minus 3 is 2. And 1 times 2 is positive 2. Add these up, and we get 0. Remainder 0, which means that x minus 1 divided evenly into the top polynomial with no remainder. And we're going to figure out what that answer is. That answer involves these coefficients. And since we're dividing x cubed by x, and you subtract powers in math when you divide, so 3 minus 1 is 2, that means our first term is 1x squared, or just x squared. Our next term of our answer is negative 3. And again, we just keep counting down in power, so that would be an x. And the next term in our answer is positive 2. And that's it. That's the final answer to this problem. Number 6 involves simplifying a rational expression. To do these types of problems, you will want to see if you could factor the numerator, factor the denominator, and see if anything cancels. If you remember your difference of two squares formula, then you would know that x squared minus 9 factors into x plus 3 times x minus 3. So the numerator factors. The denominator also factors. X times x would be x squared, and two numbers that multiply to be positive 9 that add up to negative 6 are negative 3 and negative 3. At this point, we realize that we have an x minus 3 factor in both the numerator and the denominator. So dividing by one of those factors, those go away. They basically become factors of 1, and 1 times anything is the anything. So our final answer here is x plus 3 over x minus 3. Don't make the mistake of trying to cancel the x's. Those will not cancel because they are not factors. So this is a final answer. Find a common denominator first. And these are kind of easy. If we want a denominator that x minus 1 and x plus 2 divide into, then it would have to be the denominator x minus 1 times x plus 2. So we can multiply the first denominator by x plus 2 and the second denominator by x minus 1. So keeping in mind this first fraction, in order to multiply the denominator by x plus 2 here, we would have to do that at the top of the fraction as well. It doesn't matter the order here. And if we did that, we would get 2x plus 4 when we distribute. And to get x plus 2 times x minus 1 in the denominator, we would have to multiply the second fraction by x minus 1 over x minus 1. That's the form of 1 we are using. So distributing the numerator, 3x minus 3 is what we get there. I'm just going to bring down the 1 on the right side for now. I can see that if I multiply both sides of this equation by x minus 1 times x plus 2, then it would cancel out these denominators on the left side. So I would have 2x plus 4 plus 3x minus 3 on the left, meaning 2x plus 3x, which is 5x, and 4 minus 3, which is positive 1. On the right side, I have a 1 times x minus 1 times x plus 2. So I can kind of ignore the 1 and distribute or do FOIL on the two binomials. So x times x is x squared. X times 2 is 2x. Negative 1 times x is negative 1x. And negative 1 times 2 is negative 2. You can see we have a quadratic here. Highest power is 2. So we usually move everything to one side when we have a quadratic, set it equal to 0, and solve the problem. So I'm going to subtract 1 from both sides and subtract 5x from both sides. So I get 0 equals x squared. That's this term. All of these are x terms. So we have positive 2 minus 1, which is 1x, minus 5x, which is negative 4x. And then we have two numbered terms, which add up to negative 3. Since it's not factorable, I'm going to use the quadratic formula. A is 1, B is negative 4, and C is negative 3. So x equals negative B would be negative of negative 4 plus or minus negative 4 squared minus times A times C, which is negative 3, all over 2 times A. So x equals positive 4 plus or minus the square root of 16. And now we're multiplying negative 4 times 1 times negative 3, which should be positive 12, all over 2. This simplifies further to be square root of 28. And if you recall, you want to break down your square roots by pulling out any perfect square factors. The largest perfect square factor of 28 is 4, and 4 divides into 28 7 times. So square root 28 is the same as square root 4 times square root 7. Square root 4 times square root 7 simplifies to 2 square root 7. And if we were to factor out a 2 out of the numerator, then the 2 will divide into both of those numbers that are in front there. So we will get 2 plus or minus square root 7. So we have two answers. X equals 2 plus square root 7 and x equals 2 minus square root 7. The next question involves multiplying two complex numbers. We see those i's in there, so we should be thinking of the imaginary number I, which equals square root of negative 1. So that calculation will come into play here. First, I would distribute. 3 times 1 is 3. 3 times 4i is 12i. Negative 2 times 1 is minus 2i. And negative 2i times 4i is negative 8i squared. But keep in mind that I equals square root of negative 1. And so if we squared both of these, I squared equals square and square root cancel, we get negative 1. So that's a substitution you want to make at this step. We leave the i's. 12 minus 2 is positive 10i, but I squareds, you need to substitute those out. So this becomes negative 8 times negative 1, which is positive 8. These two numbers are real numbers. They can be added together. 3 plus 8 is 11, and just bring down the 10i terms. So 11 plus 10i is the final answer. This next question is an exponential equation that we need to solve. That means that x is in the exponent level. When you see problems like this where the base on the left is a number 4 and the base on the right is a number 32, you want to check to see if they can be rewritten at a lower base that is the same base. If you go down a base from 2 squared is 4, that 2 in the exponent gets multiplied by the exponent that was originally there, and 32 is 2 to the 5th. There's a one-to-one property that says that if we have an equation and the bases are the same number, then that means the exponents are also equal. So we can basically kind of think of it as canceling these and setting the exponents equal, and then we can solve the problem from there. Distribute the 2, 2x plus 2 equals 5. Subtract 2 from both sides, 2x equals 3, and then divide both sides by 2. So x is 3/2. You could actually plug that into a calculator. 4 to the power of 3/2 plus 1. Make sure you do the 3/2 plus 1 in parentheses so it adds those first, and then it should work out to be 32. Next, we're going to solve a logarithmic equation. Log to the base 3 of x minus 1 equals 2. We could take the base of 3, go across the equals and get its power of 2, and set 3 squared equal to the argument, which in this case is the thing in the parentheses, x minus 1. So we've gotten rid of the logarithmic form by rewriting an exponential form, and this is an easy equation to solve. 3 squared is 9. That equals x minus 1. We can add 1 to both sides of the equation and get an answer of 10. We always want to make sure that the answer that we get does not cause a negative in the argument, but 10 minus 1 is positive 9, so this works out. The answer is x equals 10. This next question involves a system of equations. They're asking us to solve this one by the substitution method. To solve by substitution, we need to isolate one of the letters in one of these equations. So I'm going to rewrite this one by adding 3y to both sides. I'm going to rewrite the second equation as x equals 1 plus 3y. Now that we know what x equals in the bottom equation, we could substitute all of that for x into the top equation. So instead of 2 times x plus y equals 7, we can rewrite the top equation to be 2 times 1 plus 3y, and then we have this other plus y equals 7. So I rewrote the top equation, but instead of x, I put parentheses 1 plus 3y. Now we'll distribute. 2 plus 2 times 3y is 6y. Y is another 1y. So when we add these together, we get 2 plus 7y equals 7. Subtracting 2 from both sides of the equation, I get 7y equals 5, and dividing both sides by 7, y equals 5/7. Knowing what y is, I can easily solve for x. Right here we see that x equals 1 plus 3y, but y is 5/7. So x equals 1 plus 3 times 5/7, which is 1 plus 15/7. Since 1 is the same as 7/7, we can add 7/7 to 15/7 and get 22/7. So those are our answers for x and y, which a lot of times they want that stated as an ordered pair in the order xy. So it would be 22/7, 5/7 is the solution. This next question is a systems of equations, but they want us to solve this one by the elimination method. It's also called the addition method. In order to solve a system of equations by the addition method, we need to create either an opposite in the coefficients of x or an opposite in the coefficients of y. 2 doesn't divide into 5 evenly, but 3 divides into 6 evenly. So I'm going to try to create the opposite in the x's. And the way I'm going to do that is I'm going to leave the second equation as 6x plus 5y equals 28. The top equation, I'm going to multiply both sides by -2, and that's all 3 terms. So -2 times 3x is -6x, -2 times -2y is +4y, and -2 times 1 is -2. Now I have opposites in the x coefficients. So when I add these together, x's drop out, I can add these down and get 9y equals, and 28 minus 2 is 26. So I'm on my way to finding what y equals 26/9, and then I could substitute that into any of these equations to find the x coordinate. 6x plus 5 times 26/9 is my y value equals 28. We're going to solve this equation for x. So first I will multiply 5 times 26, which is 130 over 9. Then I will subtract 130 over 9 from both sides of the equation, 122/9. Next, I'll divide both sides by 6, and the answer is 61/27. So the ordered pair solution is 61/27, 26/9. Number 13 is a composition of two functions. They want us to calculate f of g of x and g of f of x in functional form. So f o g of x written like this is the same as f of g of x written like that. And what I like to do is substitute the g of x for g of x first. So I leave the f on the outside and I put g of x inside the parentheses. And you can see g of x is 2x plus 1. Next, I look at the f function. So f of x equals x squared. That means fing something, I don't know what you're thinking, means to square it. Okay, so if we want to f this amount, it means we need to plug it in for x and square it. So we're going to plug in this. F of 2x plus 1 means 2x plus 1 squared, which of course is 2x plus 1 times 2x plus 1, and we can work that out and find the answer. So 2x times 2x is 4x squared, 2x times 1 is 2x, 1 times 2x is 2x, and 1 times 1 is 1. And combining our like terms, we get a 4x as the middle term. So f of g of x equals 4x squared plus 4x plus 1 in this case. Now let's go the other direction and figure out what g of f of x is. G of f of x can also be written like this. Let's substitute f of x. It equals x squared. So g of x squared means plug in x squared in the g function wherever we see an x. So we're just going to change that to x squared. We get 2 times x squared plus 1, and that's it. For this next problem involving functions, they want us to find f of -1. That means we just need to substitute -1 for x in the function. So f of -1 equals 2 times parentheses -1 squared minus 5 times parentheses -1 plus 3. So we'll square the negative first to get +1. And -5 times -1 is +5. So we get 2 plus 5 plus 3. So f of -1 equals 10. This next question involves functions. They want us to find the domain of this entire function here of f of x, and they also want us to calculate what f of 7 equals. So the domain portion will be handled in two different parts. It's trying to figure out the domain of this fraction, and the other part is to find the domain of the square root. If you recall, the domain of a square root can be found by setting the radicand 2x minus 4 greater than or equal to 0. And the reason we do that is because in the real number system, we cannot take a square root of a negative number. For this function, we only need to consider what is not in the domain. And what is not in the domain is what would cause a division by 0. And the number that would cause a division by 0 is when x is 5. So basically, x cannot equal 5. We know that from this fraction because 5 minus 5 is 0 and 1 divided by 0 is undefined. So let's solve this inequality. Add 4 to both sides of the inequality. We get 2x is greater than or equal to 4, and dividing both sides by 2, we get x greater than or equal to 2. So these are the two portions that we have. X is greater than or equal to 2, but it cannot equal 5. So if we were looking at that on a number line, we would have the value 2 and the value 5. We would have negative negative infinity this way and positive infinity this way. There's nothing over here to the left of 2 because all the x's that are defined are greater than or equal to 2. So that means we would have a bracket here and all the numbers greater than or equal to 2. However, x cannot equal 5, so we would actually have a hole at 5. And the way you show that on a number line is by doing left parenthesis at 5 and right parenthesis at 5. So now let's write that in interval notation. Bracket 2 means we include 2, comma, we go all the way to 5, parentheses around 5 says 5 is not included, and then we have another interval to include, 5 to infinity. So we need to use the union symbol, which means or in math, so our solutions are greater than or equal to 2 and less than 5, or greater than 5 all the way to infinity. So that's the final answer in interval notation. Next, let's calculate f of 7. F of 7 equals, we just need to put a 7 here and here. So square root of 2 times 7 minus 4 plus 1 divided by 7 minus 5. So f of 7 equals the square root of 14 minus 4, so square root 10, plus 1/2. And that's the final answer for f of 7. The next question is a transformation. They just want us to describe how we would move the graph y equals x squared if it was to move to y equals negative 2, x plus 1 squared plus 5. So there's actually 4 transformations going on here. The first transformation in this graph is a horizontal shift. And because we have a plus 1, it's actually moving to the left 1. So that's the first transformation. The next thing we notice we have going on is a multiplication by a factor of 2. The negative we will handle as a separate transformation. So the 2 is actually a vertical stretch by a factor of 2. Then the third thing we see is the negative. Okay, the negative will reflect the whole graph over the x-axis. So it's a reflection over x-axis. Lastly, we have a vertical shift. The left one here was actually a horizontal shift, moving the graph to the left 1. This one here, the plus 5 at the end, is a vertical shift. Since it's a positive, we're going up 5. So that's the description of all 4 transformations that are happening in this function. The next problem involves zeros. They want to know what are the zeros of this polynomial function and what is the multiplicity of each zero and the behavior of the graph at each zero. So we can actually think of these inside of the parentheses as separate things going on. If we set those factors equal to 0 and solve them, we will find the zeros. So in other words, if we set x minus 1 equals 0 and solve for x, we get a 0 of the function, which is 1. A 0, another word for 0 is x-intercept. So those are points that the function goes through. The x plus 2, if you set that equals 0 and solve it, you get a 0 of x equals negative 2. And x minus 4, if you set that equal to 0 and solve it, you get x equals 4. So we found the zeros. We just need to find out their multiplicity. Now, multiplicity means how many of those zeros did we get? And we can find that out by the exponent. So this is really if x minus 1 times x minus 1, if we have x minus 1 to the power 2. So that means if we set both of those equal to 0, we would get this 0, x equals 1. Its multiplicity is 2. Now the x plus 2, that factor, when we set it equal to 0, we get the 0, x equals negative 2, and it has multiplicity 3. And the x minus 4 has an invisible 1 power, so so its multiplicity is 1. Okay, so how does that impact the graph? Whenever we have an even multiplicity, the graph touches that 0 and turns around. Whereas if we have an odd multiplicity, it crosses through the graph. So at x equals 1, we have an even number for the multiplicity, and therefore the graph is going to touch x equals 1 and turn around. And if you were to graph this equation by just changing p of x to y and plugging this whole function into a graphing calculator, you would see that at x equals 1 on the x-axis that it touches the graph and turns around. And again, that's because it has multiplicity 2, and 2 is an even number. So a lot of times they just call that touches it and turns. At x equals -2, we have a multiplicity that's an odd number, and same with x equals 4, we have an odd number. Whenever we have odd multiplicity, it doesn't touch that 0 and turn around, it crosses the x-axis at that point. So the behavior at the 0, x equals -2, is that the graph will cross x equals -2. The same is true for x equals 4. It will cross the graph at x equals 4. This problem also has to do with polynomial behavior on the graph. We can determine the degree of the polynomial by looking at the highest exponent. So this is called a degree 4 polynomial. Because it's a degree 4, meaning it's an even polynomial, we know that the ends of the graph will be going in the same direction. So the ends of this graph will either be both pointed up or both pointed down. The next thing we look at is the leading coefficient, the -3. Since the leading coefficient is a negative number, then we know that the graph will end up on the right side falling. So in other words, whatever this polynomial is doing, it will eventually fall to the right because the right side's going to end up negative. We also know that since it's even, the left and right side will be doing the same thing, so they will both be falling. Another way to say that is as x approaches negative infinity, on the x-axis, the y value is going to approach negative infinity. And as x approaches positive infinity, f of x is also going to approach negative infinity because it's falling. And that's it for this problem. We could see in this problem that we have an exponential function with a base that is e. In this case, since we're trying to solve for x, we need to get rid of that e. And the one thing that gets rid of e is taking natural logarithm. So we're going to take natural logarithm, which is ln, of both sides of the equation. And these essentially just cancel each other out. So we get 2x on the left equals natural logarithm of 5. To get x alone, which is what we're solving for, we divide both sides by 2, and that's our exact answer. Now, if they wanted us to find a rounded value, say rounded to a certain place value, then we would plug it into our calculator and round it. For instance, if they wanted us to round it to the nearest hundredths, then we would plug natural log 5 into our calculator, divided by 2, and we get approximately 0.8047. So because the next digit's a 4, we would just round here if we were rounding to nearest hundredths. But a lot of times they want the exact answer, so that's exact, and this one is rounded to nearest hundredths. Number 20 wants us to find the slope and y-intercept of this line. Therefore, we want to convert this equation into slope-intercept form, which is y equals mx plus b. So m is the slope and b is the y-intercept as soon as we get y alone. So let's solve this equation for y. We will do that by subtracting 3x from both sides of the equation. we'll get 4y equals negative 3x minus 20. Notice I'm putting the x term right after the equals so that it's in y equals mx plus b form. Lastly, we need the y alone, so we're going to divide every single term by 4. We get y equals negative 3/4 x minus 5. So our slope is negative 3/4 and our y-intercept is negative 5. If you found this video helpful, please subscribe. And best of luck to you on the College Algebra Final Exam.